Alrighty, in this video we're going to put together a method for saving and loading our component maps. Now this is really important because whenever a client connects to a server, or whenever a server connects to another server, they need to ensure that their respective instantiations of the component maps have the exact same types in the exact same order with the exact same IDs. And that's really important because there could be ways to recreate a component map on a separate computer that would almost guarantee an exact mapping, one-to-one mapping between the IDs and the methods and the types, but it isn't necessarily guaranteed for a variety of reasons. Furthermore, it's going to be a lot more flexible to be able to have the master server dictate which components and which methods map to which IDs. And that's important for a variety of reasons. In particular, we're going to be sending multiple component maps, multiple different kinds of component maps. For example, server-to-server communication might have a few different components in them than client server and so on. So I really want to make sure that the component IDs are standardized. I want to enforce that at a code level. And the easiest way to do that is whenever a client or a server connects to the master server, I want the master server to send the definitive component map. And the way that we're going to do this is with a basic binary format that I'm just going to quickly put together using binary readers and binary writers. Nothing fancy, no JSON, just something super straightforward. I'm not going to use the XML serializer or the binary formatter because both of those are awful. And so really the only option I see as being viable is to simply write my own format, but it'll be really straightforward and simple. And I'm also going to be writing this in a different class than our component map itself. The component map already has quite a few different responsibilities in it, and I want to keep it pretty separate from the concept of loading or saving a component map. So what I really want to do is just be able to write a loader and a saver, or a loader serializer slash deserializer class that's capable of, well, serializing and deserializing the component map. So yeah, stuff and things. Let's go ahead and get that written. I'm going to create a new class up here in the base project under the infrastructure namespace, and I'm going to call it component map binary formatter. And the component map binary formatter is going to have two methods. One which will return a component map called load, which will take in a binary reader, and one called, which will return void, called save, which will take in a binary writer and a component map. And really, that's about it. So let's go ahead and write a test real fast for it. I'm just going to write one test to handle both loading and saving. I'm not going to get crazy with testing either of these methods in isolation because that would require me to create it would just be a really ugly mess. So just create a simple test. I'm going to jump down here to component map tests. I'm going to go down all the way to the bottom, or I don't know, because conceptually I consider this to be a separate thing than the component map, which is why I put it into a different class. I guess I could go ahead and just write a different test fixture. So I'm going to say component map binary formatter tests. And I'm going to say test fixture. Then, of course, I'll need a couple components to test, so I'll say I test component, and I'll say void method 1, void method 2, and I'll say interface I test component 2. Now I'm going to do something really interesting with the I test component 2, because this is going to play into the most complex bit about this whole process, and that is, how do you deal with method overloads? Or how do you deal with methods that have the same name but maybe a different return type? So on iTest component 2, I'm going to write void overloaded method 1, and then I'm going to say overloaded method 1, and then I'm going to pass in a bool low. So we'll need to be able to properly differentiate between both of these methods. in a way that doesn't just use the name. And I've came up with a very simple, straightforward way of doing that just by encoding the method signature into a string and saving that out. And then, actually, I don't need to deal with return types. What am I thinking? I don't need to deal with return types because methods can't be overloaded by their return type in C#. Now, funny enough, you can actually do this in IL. You just can't do this in C#. You can do this in IL because in IL, when you invoke a method, you specify the return type. In C#, you do not specify the return type. Therefore, you cannot have methods that are overloaded just by different return types. So we're not going to worry about that particular scenario because I don't think you can do it with VB or F# either, and it seems like a very esoteric feature that I don't care to implement. So this test fixture is pretty much just going to have one test, public void can load and save component map. So I'm going to say var map. First thing I'm going to do is I'm going to arrange up a component map. Of course, this will bring in a buzz-based infrastructure. I'll go ahead and give it a reserved component ID limit of 3, just so that we can test that as well. Then I'm going to say map component. So I'll say var test component map equals map component. I'm passing type of test component, pass in a component ID of 3. Test component map method. And here's where we're going to need our method signatures. I think what I'm going to do actually is I'm going to alias out all of the method infos and all of the types into variables up at the top of this method. So before I move on with mapping my test component, I'm going to say var test component type equals type of test component. Var test component method 1 equals test component type dot get method 1. Var test component method 2 equals test component type get method 2. Then I'm going to say var test component 2 type equals type of test component 2. Var test component overload method 1 equals test component 2 type dot get methods. Now this is get method. This is where things get interesting because how do I get the method of an overloaded type with .NET? Well, I can't, because I can't just do this. I can't say overloaded method 1. I can't do that. The reason I can't do that is there are actually 2 methods with that name, so I need to specify a little bit more information to be able to retrieve the method info for this overloaded method. To do that, we can use this handy little overload of the get method, and that's going to be the one that allows you to supply an array of types, and those array of types will determine the type of the parameters to select. So in this case, I want to get the parameterless one, and to do that, I'm going to say new type 0. Now you'll notice this did bring in a using statement for system up at the top. Okay, so how do we get our test component overloaded or overload method 2 in? I'm going to say test component 2 type get method overloaded method 1, and then I'm going to pass in a new array, and I'm going to use implicit typing for the array here because I can, and I'm going to say type of boolean. And what that'll do is this will select this method, whereas that will select that method. And so it's a pretty straightforward way of getting those types there. Okay, so now that we have all that stuff aliased out, it'll make our lives significantly easier when we go to test the loading and saving of a component map. So the map.map component type of test component, I'm actually going to change this to test component type. Since I have this particular variable aliased out already into a local variable, I don't want to repeat myself with the type of test component, even though this makes no functional difference whatsoever. All right, so let's go ahead and map the method. Let's do test component method 1. And I think I'm going to do something interesting here. I'm going to say the byte ID, let's make it 2. And then test component map method, test component method 2. And I'm going to say the ID is going to be 10. So I'm kind of staggering the IDs a little bit just to give just to give a little bit more of a workout for our serializer. Okay, so now that I've mapped those, let's go ahead and map the other one. I'm going to say test component to map equals map.map component test component to type, and I'm going to map this at 10. Then I'm going to say test component to map method. Then I'm going to say test component overload method 1. I'm going to map this at 43, and test component to map method test component overload 2, and I'm going to map this at 12. Okay, so now I've created a new component map. How would we go about using the binary formatter, or not the binary formatter, as in that horrible monstrosity that lives in, I believe, system.serialization, but our binary formatter that we're writing. So what's the what is the use case, the usage of this class going to look like? Well, the first thing we need to do is instantiate one. So I'm going to say var binary formatter equals new component map binary formatter. And now what we need to do is we need to open up a memory stream. So I'm going to say var using ms equals new memory stream. Now the reason I have to do this here is because I need to write to some bytes. And to write to some bytes in memory, we use the memory stream class. Because the way streams work, this would work equally as well against a file or a network stream. So now that I've done that, I can go ahead and open up a BW, which is a binary writer, and then I can say binary formatter dot save, or sorry, the argument I have to pass into the constructor of the binary writer is the memory stream that we want to actually write the bytes into, or the stream in general, in this case a memory stream. Okay, so we're passing in BW for the binary writer, and we're passing in map for the map. Alright, so now what we have to do is we have to rewind the memory stream back to its original position, instantiate a binary reader based on the memory stream, and then have the binary formatter load in a new component map, and then we can assert against that loaded in component map. So what I'm going to do is I'm going to say using var br equals new binary reader, passing in memory stream. Before I do that though, I of course have to reset the memory stream, so I'm going to say msseek 0 begin. So what this will do is this will set the internal pointer of where the memory stream is pointing at all the way back to the beginning, so that when we start loading in bytes, then we will be loading in what the binary writer wrote to the memory stream. Now I'm going to say var map2 equals binary formatter dot load, and I'm going to pass in br. Okay, so now I have to assert against the map2 that those two methods are, or two components are mapped. So I'm going to say map2 dot components. Actually, the first thing I'm going to do is I'm going to say map2 dot reserved component ID limit dot should, which of course that will bring in using the Fluent Assertions library up at the top of the file, should be 3. Because remember, that's what we passed into the constructor of the component map. So we want to make sure that we're loading and saving that as well. Then I want to say map2.components at 3 dot type should be test component type. All right, now let's validate our methods. Map2 methods at 3 and 2. I'm basing it off of what I mapped up here. Dot method info should be same as, sure. Should be same as test component method 1. And then 210 should be method 2. Now let's do our other component. I'm going to say map2 dot components at 10 dot type should be test component to type, or sorry, should, oh come on, there you go, should be test component to type. Map2 dot methods at 10 and 43 dot method info should be same as test component overload method 1, and then map methods 1043, in this case I'll do 1012, should be the same as overload method 2. All right, that's our test. Now it's actually a little bit longer than a test should be, but I'm just sort of throwing all this stuff in here instead of breaking it out to multiple tests because I'm a terrible person. But that should be a pretty all-inclusive test into the functionality of our binary loader and saver. So let's go ahead and jump into that, and let's jump into our binary formatter. For the load method, I'm just going to return null right here. Or how about I'm going to return a new component map. I'm doing that just temporarily. The reason I'm doing this temporarily is I want to ensure that this test is going to fail. Because if it doesn't, that means I did something wrong. And I also want to ensure that it's going to fail for the right reason. I want to ensure that I don't have any maybe weird things with my with the way that I'm working with my thing. Blah, blah, blah. Actually, I'm getting a null reference exception on the declaring type because... Huh, that's weird. So the test is actually broken, so it's a good thing I ran that beforehand. Let's go ahead and see what's going on here. Test component method is null. So test component 2 type was unable to get the overloaded method 1. It was unable to get that for some reason. Wonder why. Blah, blah, blah. New array type of bool. That's a bool. They name the same. They return the same. Let's jump into our immediate window and see what we can find here. Oh, come on. All right, we can return null. It's interesting because if I don't have anything in here, it still returns null. But if I do that, it's wait a sec. What? What is... Oh, wow. Derp to derp. You guys probably already noticed this before I did. This is case sensitive, and that was a capital V right there. Anyway, so I'm glad I ran the test first to make sure that the things that I want failed. This is going to happen too because unfortunately the binary writer, after we're done with it, is going to close the stream. So let's go ahead and fix up the test a little bit. What I'm going to do is right here, I'm going to say byte, I'm going to call this saved bytes. It's just going to be sitting out here, chilling. Then instead of doing this msseek begin, I'm going to say saved bytes. Before I close the stream, before this using statement expires and calls dispose, I'm going to say saved bytes equals ms.toArray. Then I'm going to close out this ms, and I'm going to open up a new one. And I'm going to pass in saved bytes into it. So let's go ahead and reformat this code a little bit so it makes a little bit more sense. And I seem to be missing some punctuation somewhere. There we go. Okay, so all I did here was instead of using only one memory stream, I'm now using two. The first one I'm saving to it, and then I'm extracting the bytes that were written into a byte array. And then the next one I'm loading it from those saved bytes, and then instantiating the binary reader on top of it. I really don't want to deal with stream manipulation right now, so I'm not going to worry about doing anything more fancy. Okay, expected 3 but found 0. Exactly, that's exactly what I want right there. As you see that we are trying to establish the reserved component ID property as 3, but it's 0 because we're not actually loading or saving anything right now. All right, so let's go ahead and write this out. This is going to be a little interesting, the way that we're going to have to do this, particularly to deal with method overloads. Okay, for saving, what I'm going to do is the first thing I'm going to do is I'm going to say writer.write map dot reserved component ID limit. Then the next thing is going to be a little interesting. Because what I need to do is I need to be able to loop through all of the mapped components, and I also need to be able to establish how many mapped components there are. So that's actually going to necessitate me adding 2 more properties to my component map class. So let's go ahead and jump into the component map, and I'm going to add 2 more properties to it. I don't want to loop through this entire components array. That just seems a little ridiculous. I just want to give the ability to enumerate over all of the components that aren't null. And the easy way to do that is to just loop through this dictionary. So I'm going to say public IEnumerable of mapped component, and then I'm going to call this property, how about all components. I'm going to say get return types to components dot values. Then I'm going to say public int component count get return types to components dot count. Okay, so these 2 little properties are going to allow me to enumerate over all of the components easily. Even though I won't need these properties for any other purposes, they do provide a very straightforward way for us to be able to save and load a component map from an external source. So let's jump back into our binary formatter. The next thing I'm going to do when I write is I'm going to say writer.write map.component count. Then I'm going to say for each var component in map.components. Then I'm going to say writer.write component.id. Then I'm going to say writer.write component.type.assembly qualified name. Now the assembly qualified name is a string that can be used to reload a type. You need the assembly qualified name because it specifies not only the full name to that type, including a namespace, but it also specifies which assembly defined it in. And that's really important in .NET because you could have multiple assemblies with classes that are named similarly. So we really need a way to be able to distinguish between the different types, and we do that with the assembly qualified name. Now the next thing we need to do is we need to loop through all of the methods in this component, and which will require us to know how many methods there are, and also require us to have a handy little convenience property that tells us how many methods there are total. I just say that twice? I think I did. The second one was supposed to be a convenience method to loop through all of the mapped components. And we're going to do that, or mapped methods, we're going to do that in a very similar way that we did it with the component map. So I'm going to jump into the mapped component class. I'm going to say public int method count. I'm going to say get return method infos to method.count, and then public IEnumerable of mapped method all methods get return method info to methods.values. I still need to fix my resharper formatting on this computer. But anyway, all right, so now that we have that all done, we have these 2 convenience properties. Let's jump back into our binary formatter. And then I'm going to say writer.write component.method count. Then I'm going to say for each var method in component.methods. In addition, we could have just had the mapped component and the component map implement IEnumerable. I probably would have done that, but I don't want to go and mess around with codes more than I already have, so I'll just leave it as it is. So then I'm going to say writer.write method.id. Now I need to write some sort of thing that can select this method out and uniquely identify it, given the constraint that we also want to deal with overloadable methods or overloaded methods. To do that, I'm actually going to introduce a couple extension methods that will allow us to do that. I'm going to just finish my save implementation and my load implementation using these extension methods that I haven't written yet, and then I'll go ahead and write them and show you guys that implementation. So basically I'm going to say writer.write method.methodinfo.get method signature. Okay, so that's an extension method that I'll be writing later. And that's really it. That's all we need to do. We need to save our reserved component ID limit. We need to save our component count, loop through all our components, write their ID, their type, their method count, loop through all the methods, write their ID and their signature. And that's it. So now let's load it. I'm going to say var map equals new component map, and I'm going to pass in readint32. Because that is the type of, or sorry, read byte. Because that is the type of the reserved component ID limit. Then I'm going to say var component count equals reader.readint32, because that'll be this component count right here. Then I'm going to say for var I equals 0, I smaller than component count I++. We're going to say var component equals map.map component, but we'll need the type and the ID. So let's back up a little bit and alias these out of the reader. I'm going to say var component ID. Now, the order is incredibly important here. You'll notice down here in the save that I'm saving the component ID first, then its type. That means I have to load the component ID first, then its type. So I'll say component ID equals reader.readByte, which will be the ID. Then component type equals type, which is in system, dot get type, and then I'm going to pass in reader dot read string. And that's not how you spell component. All right, so right here, var component equals map.map component. I'm going to pass in the component type and then pass in component ID. All right, so now that I have the component mapped, let's go ahead and map its methods. I'm going to say var method count equals reader.readint32. I'm going to say for var I equals 0, I smaller than method count I++, or whoops, let's do j this time because this will conflict with our outer loop. Then I'm going to say component.map method, or sorry, let's go ahead and just do this. Var method ID equals reader.readByte. Then I'm going to say var method info, and now this is where something else, or another extension method will come into play. I'm going to say component type dot get method by signature, reader.read string. Then finally, I'm going to say component map method, method info, method ID. Then at the end of this, I'm simply going to return map. Okay, so these two things line up now, but what I'm missing are these two extension methods. I need a way to sort of serialize the signature of a method, and then I need a way to retrieve a method by a particular signature that was written in that format. Now, the reason I'm putting these in extension methods is I might need these later. So let's jump into our Solution Explorer, and I'm going to open up my extensions namespace. And I'm going to create a new class called Reflection Extensions. And it has to be static because it has extension methods in it. And then I'm going to stub out the first two methods. So we'll need a public static method info, which will bring in system reflection, get method by signature, and I'm going to pass in string signature, or sorry, first this type, which will bring in system, that. Now I have my get method signature. Next, I'm going to public static string get method signature, this method info that. Okay, so now that I've stubbed out the two extension methods that I'm going to need to write, I'm going to jump back into my binary formatter and import that namespace. So just by clicking that, I got the BuzzMMO base infrastructure extensions namespace imported at the top of the file. All right, so now let's jump into our reflection extensions and think a little bit about what format we should put this in. Well, I really think that the simplest way to do it would be to write the method name out and then write a delineated list of types out, assembly qualified types out for the parameters. And that will handle overloads as well as normal methods. So what I'm going to do for the get method signature part is I'm going to say var string builder, or how about builder equals new string builder, which will bring in system text. I'm going to say builder dot append that dot name, and then I'm going to say actually I'm just going to say append format that dot name, or placeholder comma that name. Actually, what do we want to delineate by? We don't want to delineate by commas because commas are going to be present in the assembly qualified name. So we're going to want to delineate by something that we're not going to see in an assembly qualified name. Alternatively, we could just write directly to the binary loader, binary saver, or binary loader, binary reader, but I don't want to do that. Binary loader, binary reader. Wow, my words are all over the place here. I'm just going to delineate with a percent sign. Okay, so then I'm going to say append that dot get parameters dot, or how about append string dot join parenthesis on that get parameters dot select, which will bring in link. T goes into t dot parameter type dot assembly qualified name. Then I'm say return builder toString. And of course this isn't going to work because we're not in .NET 4, so I'm going to have to say toArray at the end of it. All right, so all this does is it writes out the name of the method followed by assembly qualified names that refer to the parameter types. So now we just have to do the opposite here. I'm going to say var parts equals signature.split on parenthesis, or percent, and then I'm just going to say var parameter types equals parts skip 1, where t not string is null or empty t, select type get type, and then I'm going to return that dot get method parts at 0 followed by parameter types dot toArray. So all I'm doing here is I'm splitting the entire signature string by a percent sign. Then I'm establishing all the parameter types. And I'm doing that by taking the parts I just extracted, skipping the first one because that's always going to be the name of the method, specifying that I don't want to, I want to ignore anything that's empty. So if it returns any empty parts for whatever reason, we won't select those. And then finally, I want to invoke the type.getType method to select them out of. So I'm passing all these assembly qualified types into type.getType, turning them into system.types, and then returning it. Then the final thing I'm doing is I am getting a method off the type based off of the method name as well as its parameter list. All right, so that should give us a compiling application. It does. So let's go ahead and see if it makes our test run. All right, we get a null reference exception. And we get that right here for some reason. Let's go ahead and set a breakpoint right there and see what's going on. Oh, derp. I'm doing components instead of all components. And then up here, I'm doing methods instead of all methods. Remember, components and methods, those are the arrays, whereas all components and all methods are the enumerables that contain just the things that were set. All right, let's run it, and we get success. So if you guys are curious, I'll go ahead and show you guys what the method signature would look like. So I'm going to set a breakpoint right there. And then up here in my immediate window, I'm going to type in method.methodinfo.getMethodSignature. So here's an example of a method that's not overloaded and doesn't have any parameters. Let's do this again. Okay, so that's method 2. Now let's look at this overloaded method that has no parameters. Now let's look at its other one that does have a parameter. So you see the name of the method followed by the delineator, followed by the fully qualified type of system.boolean. And of course that indicates to the system that we want to load up the Boolean, the method that has a Boolean overload or Boolean parameter on it. Anyway, that was just, that's really just about it. So we now have the ability to load and save component maps, and that's going to be really, really, really important for synchronizing between server and client and server to server. All right, I think that's just about going to wrap this video up, and we'll see you guys in the next one.